this whole thing lies in the language ATM. And it says that this language is Turing recognizable. So here we are calling it recognizable but not decidable. And we know what is the meaning of decidable and recognizable. I've already explained this in the previous lectures. So here why we are not calling it decidable is because we don't know what this Turing machine M is actually doing. It may be a Turing machine that is doing some specific task that we don't know. Now if we change this W, or depending on the strings that we pass to it, this Turing machine may sometimes accept it, it may sometimes reject it, or sometimes go into a loop. We can't say for sure. That is why we call it recognizable but not decidable. Now the question is, can we have an algorithm which will tell us if the Turing machine will accept a certain string? So it says, given the description of a Turing machine and some input, can we determine whether the machine accepts it? So here is when the role of the universal Turing machine comes into play. So in universal Turing machine, what we do is that we pass into the universal Turing machine as an input the description of another Turing machine and some input values. So let's say that here we have a Turing machine called M, which is doing some task, and we have its description. That means we have the description of what the Turing machine is doing. And then we have some string W. So what we will do is we will pass the description of this Turing machine M along with the input W into our universal Turing machine, and we will run it. And then how can we determine whether the machine accepts it? Very simple, just simulate or run the Turing machine on the input. Then we can know whether it will accept or reject, or it will loop. So this universal Turing machine will behave exactly like the other Turing machine that we have, or like the Turing machine whose description we passed to the universal Turing machine. So if the Turing machine M that we have, if it accepts W, then our algorithm will hold and accept. And if M rejects, our algorithm will hold and reject. And if M loops on W, then our algorithm will not hold. So here we see that the universal Turing machine will behave exactly like the Turing machine M that we pass to it. So let me explain once more. Let me call the universal Turing machine UTM and the other Turing machine as M. So what we will do is we will pass M and the input string into the UTM, and we will see how the UTM behaves. So we know that UTM will behave exactly like how M is supposed to behave. So here these are the options that we have. It could either hold and accept or hold and reject, and sometimes it will not hold, and that is why we call it Turing recognizable, and I did not use the word decidable over here. Now in order to understand this in a better way, let us see what are the inputs and actions that we can have in a universal Turing machine. So as I told you already, the input that we have in a universal Turing machine is the description of some Turing machine which we will call M. So we have a Turing machine M, and the description of that Turing machine will be passed as an input to the universal Turing machine. And then W is an input string for M. So W is an input string that we have for the Turing machine M that we have. So these two will be passed to the universal Turing machine. And what are the actions that it will perform? It will simulate M. It will simulate the Turing machine M that we have, and it will behave just like M would behave. So it may sometimes accept, it may sometimes reject, or sometimes it may loop. So you can understand this universal Turing machine by comparing it with a general purpose computer. So we know we all have these general purpose computers, and we know what the general purpose computers do. So in our general purpose computers, what we do is we write some programs, and then our computer helps us to run that program by simulating that program on the computer. So let's say that we have a program, you have written a program in some programming language of your choice. Let's say a simple program to add two numbers. So think of that program as the first Turing machine M that you have. So you have written that program, and then the task of that program is to add two numbers. And what you do is you put that program into your computer, and then the computer simulates that program for you, and it will give you the output based on the input that you give and based on the code that you have written. So your computer is like the universal Turing machine. So you have put your program into the computer, and then the computer will behave in the way that program is written. So in the same way, the universal Turing machine will behave in the same way like the Turing machine M that you passed into it. So many times you will see that a universal Turing machine is compared to a general purpose computer. But there is a difference between the universal Turing machine and the general purpose computer that we have. And the difference is that Turing machines, when we talk about it in theory, we always saw that Turing machine has a tape and it is an infinite tape. The tape of Turing machine is always infinite when we talk about it in theory. But in a physical computer in our day-to-day life, we can never have a tape or we can never have a memory that is infinite. Yes, of course, you have very large memories these days, but they will never be infinite. So that is the main difference between a universal Turing machine and a general purpose computer. So in conclusion, we can say that the universal Turing machine is a recognizer but not a decider for the language ATM, where we have the elements M and W, where M is a Turing machine and M accepts the string W. So for this language, the universal Turing machine is a recognizer. It is a recognizer because it may sometimes accept, sometimes reject, and it may sometimes loop depending upon the Turing machine and the input. But it is not a decider because sometimes it could loop. That is why we cannot call it a decider. So that is about universal Turing machine and how it works. Now we will see the application of these universal Turing machines as we discuss more undecidable problems in the coming lectures. So I hope this was clear to you. Thank you for watching and see you in the next one.